Hello friends, this video on structure of atoms part 1 is brought to you by examfear.com. No more fear from exam. In this lesson we'll know about the discovery of protons, neutrons and electrons and also their characteristics. We'll describe some Thomson, Rutherford and Bohr atomic models. We'll understand dual nature of electrons. We'll understand the important features of quantum mechanical model of atom. We'll understand the nature of electromagnetic radiations and the Planck's quantum theory. We'll explain the photoelectric effect. We'll also describe atomic spectra. We'll state the de Broglie relation and Heisenberg uncertainty principle. We'll define atomic orbitals in terms of quantum number. We'll state of Bow principle, Pauli's exclusion principle and Hund's rule of maximum multiplicity. We'll also learn how to write electronic configuration of atoms. So having said this, we'll start the chapter. The first question that should come to our mind is, what is atom? Atom is nothing but it is a basic unit of matter. Please note, it's a basic unit of matter and this consists of nothing but a dense central nucleus surrounded by a cloud of negatively charged electrons. So if you see, atom looks like this. This is my nucleus. This is dense. It's very small. And then whatever space you see, the extra space here, right, it's all vacant. It's empty space with electron dangling from here to here to here like this. They're all empty space. The only dense thing is this guy, one the red, and whatever extra you see is all nothing but the space where you have a high probability of finding electrons. So the way you find electrons is all by probability, and that's how the atom looked like. So if you see, if you compare this dot or the nuclei of the atom with the cricket ball, this size of the atom is nothing but a sphere of radius 5 kilometers. Understand the huge thing here. This is very small. If this is a cricket ball, this is 5 kilometers. That means in the atom, most of atom is nothing but empty space. Please note, most of the atom is nothing but empty space. This is most of the atom. I'll say 99.9% of the atom is nothing but empty space. And then you have small percent, very small percent. You have this nuclei, which is dense, which has protons and neutrons, and then you have a probability of finding electrons somewhere here, and they keep moving. We'll understand this when we discuss the quantum model of atom, how the atom is or how the electrons are distributed across this atom. But just understand, atom is nothing but it's a basic unit of matter. And when I say basic unit of matter, I mean to say, if I have an atom with a particular configuration, with that I can say that this particular object will have X chemical property or X or Y physical properties. So those things we can determine easily if we know the structure of atom. So they are the basic building blocks of a matter, right? And they are nothing but 99.9% empty space and very a tiny amount of nuclei with a hell lot of space, empty space where electrons move around and jump around. And that's all the electron is all about. And it's all 3D. It's in the form of sphere. Please note, it is 3D. It's 3-dimensional. It is not 2-dimensional. It is not like a plate. It is like a ball. It is like a ball. It's 3-dimensional. It is like a ball, right? It is like a ball. It is 3-dimensional, spherical shape. Now I told what is atom. The question comes again, why study atom? Why should we study atom? What will happen if we don't study atom? So if you see the things which we use, for example, coal, the plastic bottles, the soap, the fabric, the toys, tea, coffee, medicines, everything is atom. If you want to understand the chemical reactions, you need to understand atom, right? If you see anything, lemon, balls, apple, car, the pencils, erasers used, everything has atom, right? So if you break any of these into small parts, for example, if you take this apple and you cut this apple, you get this much pie. You again cut this, and then you find something very, very small as atom. Actually, you can't see atom with the naked eyes, but that's the building block of this any matter. So with atom, if you know the atom with which this apple is made, you can tell about the characteristic of this apple or any object. So if you know atom, if you know the properties of atom, you can tell the property of the object which is made of this atom. So atom is very critical to understand. If you understand the atom, you understand the chemical reactions, and then you understand the chemistry. So before we understand the actual picture of atom, which I have shown in the second slide, let's understand the history of atom, how this atom came into picture. Because the professors are not born, right? It takes time to evolve definition of atom, and the same thing happened. So let's study the history of atom. So in 500 BC, this guy, a Greek philosopher, Democritus, this guy told that atom is nothing but uncuttable. And the word atom in Greek means uncuttable. He told that you take anything. For example, you take a mango, right? You cut this mango, you keep cutting it. Till the last point, you find a point where you're not able to cut that with the best possible instrument you have. And that thing will be atom. That's what his definition was, right? You take any object, you keep cutting it, and you reach a point where you are not able to cut it further. That particular thing is atom. And provided you don't cut with knife, you have best instruments to cut, right? So in that case, that is atom. Atom is something which is uncuttable. This was a definition given by Democritus in 500 BC, and that was the time when the word atom came into, because before 500 BC, the atom word was not even there. Nobody knew what atom is, right? So this guy gave the word atom. Then in 1805, if you see, almost 700 years after this, because this guy gave term atom, but it was just a philosophy. There was no experiment at this point of time. It was just a philosophy. Some people used to believe it, some people used to oppose it. This guy in 1805, he proposed the atomic theory, and he had some experiments done to prove this. So this time it was not philosophy, it was experiments, right? This till 500 BC it was all philosophy, that there is something called atom which is uncuttable. But in 1805, John Dalton, he proposed an atomic theory. And then in 1850, and I'll explain what John Dalton theory is just after the slide. And then in 1850, this guy, Faraday, he found something called cathode ray tube. And with that, it was easy to discover electrons. The electrons were discovered. And then this guy proposed a model, 1909. Rutherford. Thomson proposed a model, and then in 1909, Rutherford proposed a model of electron. We'll go through all this model one by one. And then this model had a lot of demerits. Then 1912, Bohr proposed a model. And please note, all these models are not correct till now. And then in 1912, Bohr proposed a model. It could answer a lot of questions, but still this model is not appropriate. And please note, when the Bohr proposed this model in 1912, he assumed that electrons are charged particles, right? He assumed that electrons are just particles. We'll explain in the next slides or next few slides that electrons are not only particles, they are dual in nature. They have wave property and particle property. We'll explain that. Hold on for that. And then 1924, this guy de Broglie gave a hypothesis on the dual nature of electron. And 1926, very near this guy Schrödinger, he proposed the equation that can tell the path of the electron, where the electron moves. And with that, they came with the quantum model. Right? In 1927, again, this guy Heisenberg, he proposed the uncertainty principle. And in 1932, Chadwick found the neutron. And then this guy found the quantum model. After this, it is not in this slide, but this is the model which is mostly accepted. This was found after all this happened. These guys proposed a model called quantum model of atom. Quantum model of atom. And that is the most widely accepted model for atom today. Right? These are all models, Thomson model, Rutherford model, Bohr model, all these had issues, they are incorrect. The correct model is quantum model of atom. Please understand this. The only correct model is quantum model of atom. All these models, Rutherford, Bohr and Johnson's, are incorrect model of atom. We're just studying this because we want to study the history of atom, but experimentally you can prove that all these three models are incorrect. In fact, we have plenty of models proposed by so many people, but we'll be studying only three models, and I want to reiterate that these models are also incorrect. They're not correct. The only correct model is quantum model of atom. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.